lesson is still based on root A times B. We're actually going to go backwards, is equal to, you can also write as square root of A times square root of B. Okay, so today's lesson we want to convert from an entire radical to a mixed radical. Why would we want to do that?
Make it harder.
Simplify it. Because it's the most simplified form. Okay. So in order to actually simplify it, what we're going to need to do is find the largest perfect square or perfect cube, based on if it's a square root or cube root, factor. Okay? So find the largest perfect square, key is largest, factor. Okay, that's what we need to do. Or it could be perfect cube if we're doing a cube root. Perfect fourth if we're doing a fourth root. If it's a square root, though, we want the largest perfect square factor. So there's two ways to solve this. I'm going to show you both ways. Mine I think is there's two ways. One I think is easier than the other. The first is actually making a factor tree for the number inside. What's this number inside called?
The radians.
Starts with the R. Radicand. Radicand. Yeah, so we want to take the radicand, just the number inside the square root, and we want to make a factor tree. So we start with 1 times 45. Okay, does 2 go into it? No, does 3? We'll go into that. Yeah, there's 2 methods. 3, so we divide by 3, yeah, 3 times. No, this is not my method. This is the other method. Okay, then does 4 go into 45? No, it's not prime factors, it's just the factors. Okay, no, we could check, does it go in? No, not. We want only whole numbers. 5 times 9, does 6? No, this is the harder way, I think, because it takes more time. 6, no. Well, 7, no. And then we're back up to 8, 9. So once we get back to the next number, we're done, because we have them all now. So you check 7, 8, 6, 7, 8, and then we know 9. We know all the other ones now. Okay? So then looking at this, what's the largest perfect square factor? Remember, these are our perfect squares. So 9 is the largest perfect square. So we're going to break it up into root 9 times root 5. 5 times 9, or 9. I like to always put the perfect square first. So 9 times 5. So that will give us, we can now use that property above. So instead of writing it under the same house, we can unmarry them, break them up. Yeah, or I don't know. I don't like that word. Okay, what's the square root of 9? 3. So it's at now simplified form is 3 root 5. A lot more work than converting to an entire. How was that so far? Okay, yeah? How do I get the 3? Because square root of 9 is 3. So we want the largest perfect square because we can actually square root 9. It is equal to 3. Okay, so that's one way. Let me show you my way. Okay, I think it's a lot faster and easier. What I do is as soon as I get into my test, I make this chart. Could you make this for yourself as soon as you get to the test on a scrap piece of paper? Yeah, why not? It'd be super easy. You can make this yourself. If you have it memorized, great. But if you have it in front of you, it's helpful. So we look at 75, and I look at my perfect squares. Okay? Now, what's the first number that's smaller than 75? The largest perfect square that's smaller still than 75 is 64. Now, if you have number sense, you know, will 64 go into 75? No. Oops. No. It's going to be at least half the size. Oh, come on, calculator. Or I guess it's the operator. I shouldn't blame the calculator. So we start dividing by a perfect square. So now we try 49. Nope. And often it's obvious. Sometimes it's not. So then I go to 36. Does it go in? No. And then last 25. So there it is, 25 times 3. Did that make sense? Because we want the largest perfect square that actually go into the number. So we're dividing by the perfect squares to see what is the largest that will go in. Okay? So instead of making a factor tree, we're just going to use our perfect square chart and find out, okay, what's the largest one of these perfect squares that goes into 75? And that's why it helps to know your squares and cubes. So root 25 times 3. Right? So now we know 25 times 3 because 25 went into it. And it went in 3 times. So that's where I got the 3. 25 times 3. Okay, so now we can break it up. And which one of these can you take the square root of? 25. What's the square root of 25? We can check in our chart. It is 5. 5 root 3. Now, can we check our answers? Yeah, we can. We can by going root 75, the original, and then our answer, and the decimal should be the same. Yeah, go backwards. Yeah, 5 squared, so 25 times 3 is 75. Yeah, and there you go. Okay, 18. So which method do you want to use? Do you want to make the factors, or do you want to go through the chart? This way? Okay, so 18. Do you want to try it by yourself? Okay, try it by yourself. Find the largest perfect square that'll go into 18 in this chart. Now, right away, you're going to start at 16 because that's be smaller than it. So 18 divided by 16. 18 divided by 9. 18 divided by 4. No. Even if you went, okay, so this is going to be 9 times 2. Square root of 9 is 3, which is 3 root 2. That's fine. You want to get to the point. My goal for you is get to the point where you can just quickly do it, right? Because you're going to have to get so comfortable with radicals. You're going to be seeing them over and over and over in the next 2 years. 3 years, I guess. Well, is it 2? 2 to 2.5? Okay, so you should have seen that 9 is the largest perfect square that goes into 18. And so 9 times what equals 18? 9 times 2. So root 9 times root 2. Or you can even go straight to this step if you're okay with that. And square root of 9 is 3. 3 root 2. And then we plug it into our calculator, make sure we're correct. 3 root 2, root 18. Okay, you're welcome to make a factor tree too. So you could have taken 18, 1 times 18, 2 times 9, 3 times 6. Their largest perfect square is 9. The only perfect square, actually. Yeah. You're not gonna, well, then you're not gonna have a super high number, like super, super high. But if that's the case, then a factor tree might be best, because then it's easier. It might be easier to see the perfect square, our largest perfect square, and you can check them to see if they're perfect squares. Yeah.
If all these radicals are square roots, why couldn't they just be called square roots? Why they have
Because the cube roots or fourth roots are also radicals. It's in that house, or same like category. Yeah. All right. So 80. Can you try this one? Square root of 80. Either make a tree, a factor tree, or find the largest perfect squares. Quinn, make sure you're working on this. Grab a calculator. So find the largest perfect square that goes into 80. Where's my calculator? So I'm going to show you something. Now with 80, what was the largest perfect square factor? What was the largest perfect square factor? Was 4 the largest? There's 4, and then there's 16. Who's larger? 16. So we'd actually want to use root 16 times root 5. Okay? So, and what's the square root of 16? 4. Now, did anyone accidentally use 4 times 20?
Yes.
Okay, if you use 4 times 20, let me show you something. If you use 4 times 20, guys, just listen up, okay? Then you would have had 2 root 20. Square root of 4 is 2. Now, 20, is there a perfect square factor that goes into 20? 4, right? So is this fully simplified? No, because now we could still break up the 20 into root 4 times root 5. Because perfect square, 4, will go into 20. What's the square root of 4? 2. And so what are all these three, what's going on between these three numbers? What's operation is happening? Multiplication. So this becomes 2 times root 5, or what's 2 times 2? 4 root 5. So we can get there, but then it's more work if you don't use the largest perfect square factor. Okay? So it's very important that we find the largest, lot easier and quicker if you use the largest perfect square factor. Okay? All right, let's go down to the cube root. Skip E. So we now want the largest perfect cube. The largest perfect cube. So 32. Okay, so we're going to look at this part of the chart now. These are our perfect cubed. So 64 is too big, so you're going to start at 27. Will 27 go into 32? No. It definitely won't. Okay, what's the next one then? 8. Will 8 go into 32? Yes. 8 times 4. So we're going to write this as the cubic root of 8 times 4. And now, what can we do with those? Break them up. So sad. Okay, so now we got them split up. Which one of these can we take the cubic root of? 8. Cubic root of 8 is 2, right? We can see that right here. 2. So cubic root is 2 cubic root of 4. Okay, so checking your work. Cubic root, where do you find that? Math 4, 32, and then 2, math 4, cubic root of 4. Should be the same decimal. Okay. All right, try G on your own. Try G on your own. So find the largest perfect cube that goes into 250. So twice. So 125 times 2. Okay, then we break them up. Yeah. Okay. Yeah. Yeah, I could. Yeah. Absolutely. So then all you got to do, if that happens, is just add a category. X to the 4, make your own. 2 to the power 4 in your calculator, you can figure that out. And then you know your perfect fourths. Yeah, it's squaring your square, right? 16, 9 squared is 81. Okay, so what's the cubic root of 125? It's 5, so we have 5 cubic root of 2. All right, let's look at this guy. All right, so we can remember, because of root of a times b equals root a times root b, we can also split up all of these. Okay, now which one of those can we simplify for sure? 20. 20. Is there a perfect square that goes into 20? Yes. Yeah, which one? 4. So we can actually take 20 and make it root 4 times root 5. 4 times 5 is 20. Okay, square root of a squared. Well, what happens with square roots and squares? Cancel each other out. So that's just going to be a. And b to the power of 4. What happens when you square root b to the 4? B squared. It cuts it in half. B squared. Okay, we can do one more thing here. What's the square root of 4? 2 root 5 ab squared. Where do we get the 4 and 5 from? Okay, so from 20, we had 20. And looking at my perfect square chart, 16 won't go into 20, 9 won't go into 20, but 4 does. 4 times 5. So 4 is a perfect square that goes into 20. So root 20 is root 4 times root 5. Do you want to try the next one? Yeah? Then you would leave it inside the radical. Like here, like these ones? Or like it doesn't, so like root 10. So like root 10 cannot be simplified anymore because 4 or 9 doesn't go into it, so you just leave it as root 10. It's fully simplified. Yeah? Yeah. Square root of a squared, like the square root and square cancel each other out. And the reason why this is 2, it cuts it in half, you could also write this as b squared squared power 4. Okay, is another way to think of it, guys. So then this square root and square cancel out. It's another way to think of it. Or when we square root a variable, it cuts that exponent in half. Okay, and that's why it became b squared. So square root of b to the power of 6 would be b cubed. All right. So 50. Looking at 50, it's the largest perfect square factor that goes into 50. Well, let's start at 49. Yeah, if you know your times tables, does it make this a lot easier? Yeah. Otherwise, you're sitting there going like this until you get to 25. 25 times 2. So we're going to break these all up. So we can go straight to 25 times root 2 times the square root of a squared times the square root of b squared. I'll show you after. Okay, what's the square root of 25? 5 root 2 square root of a squared. A square root of b squared. B. Yeah. All right. We have to look at next page. We're almost done. I promise you we're almost done. Okay, so what does it mean to fully simplify a radical? We're not done our notes.
Yeah.
Right?
I have them right here.
Okay. Okay, so specifically the radicand is what's important. The radicand should not be divisible by any perfect square if it's a square root.
Just wrote radicand should not be.
Oh, should not be divisible by any. Thank you, Anthony. By any perfect squares. Okay, it should not have any perfect square factors. Can't Quinn, you should be taking notes. Put that away. So these radicals, what's different about these ones? They already have a coefficient. However, they're still not fully simplified. So just because it has a coefficient doesn't mean it's fully simplified. Okay? Because looking at 20, does 20 have a perfect square factor? Is there a number that will divide into 20 here? 4. 4 times 5. Okay, so we still have some work to do then. So root 20 can be 4 times 5, or let's break it up into root 4 times root 5. Now it's all multiplication between all three of these. So what's the square root of 4? It's going to be 2. So what are we going to do with the 2 and the 4? It becomes 8. We multiply them. It's 4 times the root of 4. 4 times 2, so 8 root 5. Okay? So I just wrote above because really what this is 4 times 2 times root 5. Okay, when you square root of 4, it's 2, but you have to multiply by the coefficient in front. Doesn't matter. Just the radicand can't be divisible by a perfect square. Okay, so 50. So looking at our chart, we're going to start what number? 49. So, okay, me pretending I don't know anything about numbers, I start dividing by all the perfect squares smaller than 50. And we go backwards. 36, then 25. Oh, and there it is. 25 times 2. Awesome. So we're going to write this as 3. We can go right to writing as root 25 times root 2. Yes.
Even if you didn't have the chart, what you could essentially do is find the approximate square root of the number that is in the that is the radicand, and then round that down and find if the squares.
I don't know if that'll work, Anthony. Okay, what's the square root of 25? 5. So, what are we going to do with 3 and 5? 3 times 5 is going to give you, so square root of 25 is 5, so we have 3 times 5 times root 2, or 15 root 2. Okay? Not yet. 2 more. 2 more. Okay. Fine, that's okay. It's on the next page. Oh, it used to be like day 3 and day 4 used to be in one worksheet. So it should just be that worksheet. Yeah. Okay, so root 12. Is there a perfect square factor that goes into 12? So looking at 9, does 9 go into 12? No. Does 4? Yeah, 4 times 3. So we're going to write this as 5 times root 4 times root 3. What's the square root of 4? 2. 5 times 2 is 10 root 3. Okay. All right, one more, but with cubic roots. Uh-oh. So we want to look at which part of the chart? The other side, the perfect cube. So starting at, if we have 54 as a radicand, next is 27. So we check, does 27 go into 54? Twice, it does. So we're going to write this as 2 times the cubic root of 27 times the cubic root of 2. Because 27 times 2 is 54. Now, we know one of those is a perfect cube because we divided by the perfect cube. What's the cubic root of 27? 3. So we're going to go 2 times 3, or 6 cubic root of 2. Will you lose marks if you don't write the cubic root part? The index, yes. The index is super important. You have to write that little 3. If it's a square root, do you have to write a 2? No. Okay, so there's 2 parts to your homework today. The first part is the worksheet on the next page. That would be page 65. Is that right? Worksheet page 65. And the answers are on page 66, so you can check, or just below it, I believe. Yeah, so you can check your work. Once you're finished the worksheet, so do this first, then start page 218. Okay? Now, if you're finished early, what should you work on? study sheet, yeah. And then other homework if you have it. You can work ahead as well. Also, today I'd like to hand back your tests. Okay, so we're going to pack up in about 20 minutes. But it's still, like, this is not a super long assignment.
Just out of curiosity, does this calculator have like one of those little
Let me
percent
push stop.
signs that allows you to find the